On today's episode, what you need to know about the 5G risk to aircraft. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. We all know that information is power. Data is everything, and everything from our smartphones to quantum computers handle more of it faster than the science fiction of 30 years ago could even imagine. But processing data is always dependent on moving data. In today's wireless world, the need for speed has spawned 5G technology. Now, put simply, 5G is a radio frequency technology that uses short wavelength radiation to encode more information per unit time than was possible with older, lower frequency radio. Higher frequency is desirable, and it's desirable for many applications. And to prevent crosstalk chaos, the FCC in the US allocates bandwidth with an auction process. Now, 5G operates in a range of frequencies called C-band, which in the US are radio frequencies between 3.7 and 4.2 gigahertz. Now, this is high-frequency stuff, and many competing interests operate devices that use those frequencies, including everything from induction heating and nuclear fusion research to baby monitors, and unfortunately, radar altimeters. What's a radar altimeter? Well, it's the primary instrument used by commercial aircraft to determine how high an airplane is above the ground. It's a fundamental instrument in aviation, and it's vital in this day of blind landing capability and scheduled airliner operations in conditions of low visibility. Now, as the name implies, radar altimeters work like a radar set except pointed downward. High-frequency radiation is transmitted down from the airplane, is reflected by the ground, and received back at the airplane. The instrument then uses time of flight and frequency shift to infer altitude with precision and accuracy that even allows completely blind landings in commercial service. Now, it goes without saying that other transmissions on nearby frequencies have the potential to jam the signals, with potentially disastrous effects for aircraft approaching a runway. Now, not all aircraft have radar altimeters that are susceptible to 5G interference, and the FAA has already approved most Airbus aircraft and almost all current Boeing airplanes as safe in 5G regions. The effect on regional airliners is still under review by the FAA, and regional jets not only feed the major hubs in the US, but they form an increasing part of point-to-point scheduled service as well. So what happens if flights are restricted to good weather only because of 5G? Well, chaos. Now, the strange thing is that in Japan and Europe, 5G is already rolled out without any issues for aviation. In France, for example, 5G signal strength is 2.5 times lower than in the US, and 5G safety buffer zones around airports are restricted to interference over the last 96 seconds of final approach compared to 20 seconds in the US. France requires that 5G antennas also be angled downward to minimize interference. Now, one consequence of these regulatory differences is that the French model would require more transmitters to deliver the same service in areas near airports. Now, none of this is rocket science, and it surprises me that with something like 4 years of study ahead of the 5G rollout, that this is even an issue. Now, everyone has known that 5G was coming for years. It's almost as if one branch of government doesn't communicate well with another. Now, they'll fix this simply because they have to, but in the meantime, for those of us who ride behind the cockpit, it's important to know two things. One is that the cell phone in your pocket is not the source of the trouble, it's the network transmitters. And the other is that the FAA is simply not going to allow commercial aviation to operate where 5G signals can disable aircraft systems. Now, that's nice, but it's cold comfort when your flight is canceled due to weather. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.